We're going to look at the element silver. Silver has 47 electrons. Well, it has an atomic number of 47. So that means it has 47 protons, which are positive. But since most atoms are neutral, normal atoms are neutral, it also has 47 electrons. We are going to figure out where the electrons go in silver. Remember, this is the order in which they fill up. Okay, so remember, these numbers indicate the energy levels. So these are the energy levels. Main pathway the electrons travel through. All right, but in that pathway there are sublevels. And remember, each energy level, whatever number that energy level is, it has that same number of sublevels. So energy level 1 has one sublevel. Energy level 2, two sublevels. Okay, the letter then indicates the sublevel. So the letters, like S, P, D, F, although we don't have F in this one, right? We might need it though, we'll see. These are the sublevels. And remember, the S stands for spherical. So if the nucleus of the atom were inside this balloon, I could use this balloon to represent the path upon which the electrons would travel in an S sublevel. So it would be spinning around. So we're representing the balloon by indicating inside, it's mostly space, except you'd have a nucleus in there. But the outside would represent the pathway upon which the electrons travel. Remember, the P sublevels are like dumbbell shaped. So think of like a figure 8. One electron would be up here, one would be down here. And they spin. And when they spin, since there's two of them, they spin in opposite directions. You don't have to worry about that. It's Pauli exclusion principle. It's very advanced chemistry. You don't have to worry about that. But they're going to be spinning in opposite directions. But think of this as like a figure 8. All right, so this is one of the orbitals of the P sublevel. But remember, the P sublevel is made of 3 orbitals. So 3 of these. So 3 p orbitals. And it can hold 2 electrons per orbital. So one electron will be up here, one will be down here. So now if we look at the p sublevels put together up here, you can see it can hold a maximum of 6. 1, 2, 3, 4, 5, 6. Because the atoms are 3-dimensional, so we're looking at 3 dimensions here. This one, it can be a little challenging. Okay, so we have sublevels, we have energy levels. Now, 47 electrons. So we're going to figure out where are these electrons going to go. Okay, this is the order in which we fill them. Okay, so this is like first seat, second seat in the roller coaster. Over here, people get excited. Some people don't follow the rules. They don't stay in line. They skip over to the 4th row instead of the 3rd. So sometimes it doesn't go exactly like this. So if I have 47 though, I'm going to write this out, and the exponents then will indicate the number of electrons. So, whoa. Whew. Gotta get back to the black. Okay, so here we have 47. So 1s, this means number of electrons. Okay, so the exponents here are going to indicate the number of electrons. Okay, we fill up the first S sublevel, 1s2. So we're down to 45 electrons left. Okay, 2s. 2. Right? So we're down to 43 electrons. 2p. Remember, P can hold 6 electrons, right? This is an example of the p sublevel right up here. 6. So now we have 37 left, 37 electrons left here. Okay, the next one, 3s, can hold 2. So now we have 35 electrons left. 3p can hold 6. So now we're down to 29. 4s can hold 2. 27 left. 3d can hold 10 electrons. So we're down to 17 remaining now. So now, in this case, we have used up the 3rd energy level, and we're starting the 4th. So now we did 4s, we're going to do 4p. Can hold 6. So I'm down to 11. 11 left. Next thing, we're going to go to 5s. So that's 9 left now. And we're going back to 4d. And that can hold 10, right? But we don't have 10, we have 9. Okay. Here is the electron configuration of silver. You write this out, do it in one line, one row. Okay, I ran out of room here. So now we're going to draw a Bohr model of a silver atom. So here we have the electron configuration of an atom of silver. Okay, so silver has 47 electrons. Now, we're going to use this electron configuration to make a Bohr model of a silver atom. Second energy level holds 2 plus 6, 8. When I draw the Bohr model of an atom, I'm not showing the sublevels. This is the way I did it the first time. I wasn't showing sublevels here. Okay, so we've done, these two are done. Third energy level now. Third energy level, we have 2, 8, 18. Okay, so we've gotten, that's our fourth energy level. 2, 6, and 9. So we have 17 in the fourth, and the fourth. Okay, so 17 out there. Not filled up, you'll notice, because this one, the fourth one can actually hold 32. Remember the first one 2, second one 8, third one 18, 32. Silver is actually a transition metal. So you cannot determine the number of valence electrons from transition metals by looking at the periodic table. All right, so silver actually has a valence number of 1. So that means it has 1 electron in the outer energy level. So instead of 2, you would have 1. Sense. Look at this. Remember those empty rows. Electrons do not like to be in long, empty rows. So if they're going to be alone, they want to be alone in a short row, just like on the roller coaster. You're okay if there's only one other seat and it's empty, but you're not very comfortable if the entire row of like 10 seats is empty. Remember, they also like to fill up the rows. So just like you don't want just one electron in the row, you don't want just one person in the row, you also don't want a row that just has one empty seat. So you want balance. So the roller coaster would be on balance, let's say. If there's one empty seat at the very end, or there's only one person in the entire row, and they're at the end, it wouldn't be balanced. Okay, so if we look at this, remember the D sublevels can hold 10 electrons. So you would not, the electrons naturally would not only want 9 in that sublevel, they would want to fill it up. It is not 9 in the D sublevel, but 10. And it is not 2 in the 5th energy level of the S sublevel, but it's 1. So there are not, the electrons want to be stable. They don't want just one empty seat in the entire row, or they don't want just one filled seat in the entire row. Looking for balance. Nature is looking for balance. There's balance in nature, symmetry. All right? So this is a review of the electron configuration, and I want you to practice setting up electron configurations for the atoms that are listed in the YouTube description. So you're going to write this down, and you're going to use this for the 10 different atoms that are listed in the YouTube description. And what I want you to do is just write the name of the atom and its chemical formula. So for example, sodium, Na. I'm going to write this out, and I'm going to use the numbers as exponents for the number of electrons that are present in that atom. Now, if you only get to like 2p and you run out of electrons, you don't have to write the rest, then you're going to erase the rest of this. Okay, because it doesn't have, let's say, if we're going to write the electron configuration of helium, for example. Helium has 2 electrons, that's it. So, for helium, I would write helium, chemical symbol, helium 1s2. So this is the electron configuration for helium. 2 electrons. They're both in first energy level, S sublevel. That's a simple example, but this is the order in which you fill up the electrons. And remember, S sublevels takes a maximum of 2. P sublevels, maximum of 6. D sublevels, maximum of 10. And F sublevels, maximum of 14. Orbitals inside these only take a maximum of 2 electrons. So there's 1 orbital in the S sublevel. There are 3 orbitals in the P sublevel. Remember I showed you. Remember I showed you this? There are 3 of those dumbbells. This is 1. There's 2 more attached here. You put them all together. There's 3 orbitals. All right, this one has 5 orbitals. This one has 7 orbitals. So you might see a pattern here. I want you to think about it. What type of pattern are you seeing here? So we have 1 orbital, 3 orbitals, 5 orbitals, 7 orbitals. Okay. You are going to put the number in the exponents above each of these sublevels according to how many electrons are present in the atoms. So right now, test it out. This is a challenge. Let's see if we can do some electron configurations. Woo! Have fun.